Hello, good morning. My name is Afonso Garrido, and today I'm going to talk about Bluetooth. This individual presentation and data communication, CS 504. So before I start, I would like to apologize about my English, since I'm is not so good. And second, about my voice. I got a flu, really bad flu. I tried to do my presentation yesterday. It was worse, but today, luckily, I can talk. Let's talk. In my agenda for today, we're going to talk about a little bit about the story of Bluetooth, and then I'm going to talk about inside of the story how the master and slave related, frequency hope in the spread spectrum. Also talk about the time division and PICNAT and SCARNet. Then I'm going to talk about the protocol stack, the radio layer, the base band layer. That's going to be inside of this the device tracing, frequency hopping, a little bit about logical and error checking control, and finally talk about insecurity. That is the main point of all communication. If we don't have security in communication, we have a lack of communication, because other people can come in listen to our communication, or either listen or whether interrupt our communication. So then, before we go straight to our presentation, I want to try start to give a definition of Bluetooth that is nothing else than a wireless communication. And this communication just allows two devices to change information between each other. It's universal and have a short range wireless capability. So that's mean Bluetooth don't go like 100 kilometers or like a big distance. So use a gigahertz band frequency that is 2.4 gigahertz is available globally. So you can find Bluetooth anywhere in the globe. And like I said before, the range is short range is like 10 meters. And in 10 meters, we can shut up to 21, from 2.1 megabits or 24 megabits of capacity. And what we can share with Bluetooth network, this wireless connection, we can share data, audio, graphic, video, and so on, so on. So, but before we go, I would like to talk a little bit about the story of Bluetooth. In 1994, the Bluetooth specification emerged from a study undertaken by Ericsson mobile company. We know that Ericsson used to be one of the biggest telecommunication company, and in 1994 they start a study about Bluetooth communication. So then in 1998, not only Ericsson, but was Ericsson, Intel, IBM, Toshiba, and Nokia. They start like they found a Bluetooth special interest group. So it was a group that was completely interested for Bluetooth communication. So by 1999, they published the first version of Bluetooth, was a 1.0 Bluetooth specification. And then year after that, many hundreds of companies just joined this Bluetooth special interest group as a Bluetooth adopters company. So, but when you talk about Bluetooth specification, compromise two parts. The first, as we talked before, is the core specification, which define the Bluetooth protocol stack and the requirement for testing and the qualification of Bluetooth-based products. So the second profile specification, which define uses models that provide details information about how to use the Bluetooth protocol for various types of application. Then we have to talk about how this device that use Bluetooth connect each other. In one hand, you have the master. So another hand, you have the slave, and all device must operate either as a master or as a slave. The master is the device that initiates the communication with another Bluetooth device. And the master has the responsibility to make sure that the communication link and traffic between itself and the slave device are going to be the right one, going to be the right channel. And later on, we're going to talk a little bit about channel. So, and this is the responsibility of the master. On the other hand, the slave is the device that responds to the master device. So the slave they are required to synchronize the transmitter and receiver time with the master. So when they start communication between both devices, so one is the one going to be the master, another one is going to be the slave. And this relationship will be for the communication between those two devices. So, but how this communication happen? So this communication happen in correctly and the right frequency. And one thing that happened when they have this communication calls frequency hopping spread spectrum. And what exactly this? The Bluetooth employs the frequency hopping techniques to ensure security and robust communication. So that's mean the hopping scheme is such that the Bluetooth device hop from 1 megahertz channel to another, and without like a random manner that's happened so normal from one frequency from another with the same 1 megahertz. And the good thing about this was defined by the group, special interest group that created to talk about Bluetooth. But it's important to say that there are 7-9 channels to define which channel, 7-9 channels that can be occupied for this communication. So when the hopping happens, they can happen from channel 1 to channel 7-9, or from channel 15 to channel like 55. And this is going to be a jump from one channel to another. And normal, each hop just lists 625 millisecond, and but by the end of this 625 milliseconds, so they change to a different channel to make sure that we're going to have a secure communication. And what happened? This happened two things. Happened the PICnets and the SCATnet. Because all the Bluetooth communication are haddock network, and all the devices share the same frequency hopping spread spectrum channel. PICnets can consist of so in other words, PICnet is like in this network there is 8 devices, and one device is going to be the master, and another 7 device can be the slaver. So this is a relationship between one to many. They're like, when this relationship happens in Bluetooth network, that's mean that they have a good relate communication. So, and when this happens, and one device can connect with another 7 ones, so we have a PIConet. And the frequency hopping sequence of PICnet is determined by the Bluetooth device address That's as known as also as known as BDRD address, and must start of master device. At the time that the picnic is established, the master device address and clock are communicate to all slave device, all the picnic. Then we have scatternets, and just create when a device become an active member of more than one picnet. Essentially, the adjoint device shared at the same time slots among the different picnets. So this happens when one device can be like in more than one Bluetooth communication. And a good example for this is the Apple computer. The Apple computer or iPod, the iPod. And the iPod, like the AirBags that I have, I can connect at the same time on my computer, my laptop, my MacBook, my iPhone, and also my iPad, the same device. So each be hopping and change from one device to another device to give me information. So whatever I'm doing, if my iPad start the audio, it just jump from my computer, my iPhone to my iPad. So then we're going to talk about protocol stack. So when we talk about protocol stack, we have a couple of options. We can talk about the core protocol, the cable replacement protocol, adapter protocol, and so on. But the most basic and the most like interactive protocol in Bluetooth is the core protocol that includes the radio, Bluetooth radio, baseband, and the link managed protocol, also known as LMP, logical link protocol, and adoption protocol, that is like L2 CAD. And finally, service discovery protocol is the SDP. So, but because Bluetooth is a wireless communication, there's also cable replacement protocol that is include radio frequency communication protocol and it's a short radio front end component. It's a provider serial interface of wireless application protocol. And then we have adopted protocol. Like I said before, Bluetooth is a wireless communication protocol. These are the protocols that are adopted from standard models, and the common protocol that you can find it is like point-to-point protocol, PPP, triple P, internet protocol, that is the protocol that used in the internet, use diagram protocol, UDP is transmission protocol, also TCP control protocol, and finally, wireless application protocol. So when you come to a little bit layer, we're going to find the radio layer. The radio layer is the lowest layer of Bluetooth architecture that corresponds exactly like the same layer in Modelo OS, that's the physical layer. And like we can see here in this diagram, the radio layer is the last layer, is the physical layer, is the same range as baseband. So it's a baseband layer, I'm sorry. So we could have, we have like the data link layer, and then we have like, in data link layer, we can find the logical link control adaptation protocol. We can also find the middleware layer and application layers that we're going to have profile. And it's important to say here in the medium wave layer, we can find like wireless application, TCP, UDP, IP and the PPP, and that's commands. All those are in middle layer. So in this layer is the layer that's make sure that we're gonna have all the connection and the median gonna be transmitted by this layer. So then we're gonna come to the base band layer. So in base band layer, is one of the most complicated protocol of Bluetooth communication. But we can find here a couple components. For example, device addressing, the radio transfer for each Bluetooth device is assigned for a unique 48-bit Bluetooth device addressing that we also call BD address. That was a frequency manufacturing. So we also find the frequency hopping. The Bluetooth is a frequency hop from one frequency channel to another frequency channel. We talked a little bit about the frequency hopping before. That mean that like they don't stay in the same channel forever. And the typical hop occurs once at the beginning of every time slot, because of which that we say before, slots has only 625 milliseconds duration. So for the nominal hopping frequency is 1,600 hops per second is a lot of hops. So, but we also talk what happened when you share a message in Bluetooth. When you share a message in Bluetooth, we share a package. Like all communication, the package has a correct format. In the Bluetooth, you have three main points to take a look or to have in your mind. First is access code. The access code is used for timing synchronization, offset compensation, packet and encode. Then we have the head. The head is used to identify the packet type and carry protocol information. Finally, we have the payload. The payload contains the voice or data and payload header if it's present. So down here, we have like a diagram that we can see. So when you have like a packet, we can see this packet. Let's see. We can see this packet around here. What can I do here? I think here. We can see this packet around here. I'm gonna try to draw. I don't think it's a good idea. Yeah, so I'm coming back. So when I have a package, you can have like a package format, like we have a preamble, access address, video. So, and if you go to the package format, you have like a 1 to 2 bytes for preamble, 4 bytes for access address, and like 2 more bytes for PDU and 3 bytes for CRC. So, and when we split this package, we're gonna have like a PDU format, and then we're gonna have a payload format. That is really interesting. But every parts have like standard headlines and advice data. So, but we have also channel control, and channel control deals with the establishment of the picnets and add and remove device to or from a picnet. So this channel control has the responsibility to define what priority is going to be inside the network talk between device. And the two primary states that you can find in channel control is standby and connectors. one device can be standby state if in default low power state. So then we're going to find, error shaking correction. So every device has like an error shake connection and correction. So when a packet is received, the receiver immediately check if the channel access to the code. Recall like CAC, it's the preamble for all the packets. We talked about preamble before. And the CAC embedded in the packet does not match the CAC of the picnet, then either the packet was receiving error or the package was destined for another picnet. In either case, the package is discarded. So when the packets come, first of all, they check if the packets had the same, I can call number address from the one who sent and other received. If it's a match, yes, the communication is going to be established. If not, so we're going to have an error and the packet is going to be discarded. So here we can see this diagram that show how this work. For example, in the first transmission, the payload, CSC generation payload, and send the codes, and we check for error. So if the receiver payload says true, this pass, so then they receive the payload and decoded the payloads. If they say if they say no, it's not true, fails, it is drop the package. So let's move on. So when it comes to security, because Bluetooth is a radio frequency-based wireless technology, that exchange between Bluetooth device can be easily intercepted. But at the baseband lower link level, the facility for link security between two devices relies on two different procedures. First is authentication. The second is encryption. When it comes to encryption, so Bluetooth communication don't climb to another device identity is the normal procedure. And when it comes to encryption, the procedure used to encode user data, so data is unintelligible until the code uses a specific key. So today what we bring for talk about Bluetooth. I would like to apologize about my English or other situation. Those are the reference that I use to do this work. I'm sorry also about my voice. I was extremely sick with the flu. I guess I'm going to be okay. Thank you very much. And I will stop right here.